September 17, 2013. I'm still waiting for newer data to come in, but that's okay. We can use the data we've got right now. And what's interesting about this is, for the second year in a row, the proportion of Americans without a health care insurance declined. Declined. This is before Obamacare kicked in. I mentioned that just because that's really what's in the news right now. Yeah. But according to data that came in, and this is from, I forget the source, oh, Census Bureau. Census Bureau. The proportion of uninsured was declining. The question I have is, how fast was it declining? Is there one fewer person or 1 percentage point less than last year that are uninsured? That might not be worth writing home about. So what I want to do is I want to figure out some way of measuring that. And it's interesting. In 2012, the Bureau said 15.4% of people were uninsured, down from 15.7% in 2011. That doesn't make me, like, stand on the desk and dance. 0.3 of 1%. So that's 3 out of every 1,000 people, right? A percent would be 3 out of 100. 0.3 is 3 out of 1,000. Now, I'm stoked for those 3 people out of every 1,000. I'm not saying I'm not stoked. But my question is it even 3 people out of 1,000? Because these numbers have margins of error on them, which we'll get into as well in this class later as we get. So when I kept digging, I wanted to keep digging on this one. So I found in old Census Bureau data a little bit of a trend. So here's the years, 1992, 1994, 96, 98, and 2000. And those were rounded off to the nearest million. The number of uninsured folks. The number of uninsured folks in those years. Now if you look at this, 35, 38, 39, 41, 44, where are those numbers going? They're going up. This seemed to me to counter what the article was saying. But then I read it again. They were talking about the proportion of people being uninsured, not the number of people being uninsured. See the difference there? The proportion of those being uninsured, not the number being uninsured. What's the difference? What's the difference between the proportion of those, I'll change the word, the percentage of those being uninsured and the number of those being uninsured? What's the difference there? Help me out. What's the difference between the number and the percentage? Oh, please. Will? Yeah. Will, go ahead.
The number is the actual number percentage you're comparing it to 100.
Exactly. So the number, in 1992, according to this, there were 35 million uninsured Americans in, what, America? Uninsured Americans. What was the percentage of uninsured Americans? What else would you have to know to calculate that?
How many there were in total.
How many Americans there were, yes?
Yeah, and population. Can you repeat that?
Sure, absolutely. Will, say it again.
So the number is the number.
So, to expand on that, a study was done, and it was either determined or it was extrapolated that there were 35 million Americans in the country without health insurance. So 35 million, which is a huge number, yes? Then my question is, how about the percentage? Because this article speaks of percentages. You would have to take the 35 million and divide it by what? The total number of Americans that are in the country at that year. The total number of Americans that year. So it's possible that this doesn't disagree with this. This could go up each year, or each every couple of years like this, and the percentage could actually go down, couldn't it? You could have the top number of a fraction go up if the bottom number of the fraction goes up faster. So in other words, the division could actually go down, whereas both parts of the fraction. We'll see that momentarily. I have the actual crunch of the data. But rather than get the population involved in this, although it is important to get it involved, I've mentioned this to you before, very often we lose track of the big picture when we focus just on this. You guys hear this all the time statistically when they talk about the next blockbuster movie that came out. You know, the next what was the biggest grossing movie over the past 6 months?
Frozen.
What was it? Frozen?
They were saying Frozen beats Star Wars or something or whatever.
Only in raw value.
I don't.
I agree with that statement. I guarantee that Frozen, which uses an animated movie. I don't know.
I don't know.
I've heard a few things about it. It's good music. Got music apparently. So, okay, it wasn't horrible. No, it's fine. But I'm sure that it actually brought in more money than Star Wars Episode 4 did in 1977.
Because the population was up. That's exactly what I was
That's one thing. More people probably have the opportunity to go see Frozen than had to go see Star Wars Episode 4. Ticket prices were a hell of a lot more now than they were then. If you adjust for all those variables, Star Wars kicks out of the park. If you adjusted for inflation and you actually weighed it properly. So that's, yeah, I'm with you on that one. You have to adjust for all that stuff. I guarantee it made more money. Only, I think, 2 movies in history have made more money once you adjust for inflation than Star Wars Episode 4. One was Avatar, and one, I believe, was Titanic. I think. Those are the, once you adjust for inflation, I didn't even adjust for ticket prices, but just for inflation. In other words, applying a 2% increase to each dollar each year. Does that make sense if I say that? So essentially, $1 in 1977 would be worth $1.02 in 1978, would be worth just over $1.04 the next year. If you keep that going for 40 years, $1 is worth a lot more than it was worth back in the day. It's worth about $2. It's worth twice, essentially. So, yeah.
Well, I was listening to the radio and they said the Marvels movies are now, they passed Harry Potter.
In what way? Adjusted for inflation or unadjusted for inflation? In raw amount?
But raw amount.
Well, that would, all you gotta do is keep making movies and you're gonna do that, right?
Yeah.
I mean, right? All you gotta do is keep making movies. Eventually you're gonna make more money than Harry Potter did. I mean, absolutely, right? If you just keep making more movies and you add them all up, eventually that dollar amount's gonna be more. But the question is it meaningfully more? Is it worth talking about more in a meaningful way? I don't know the answer to that unless they adjusted for inflation, which I guarantee they probably did. Because I don't think the movies did that well. Yeah?
But if they take the monetary portion of that out and they just go ticket sales to ticket sales.
Sure. You have to adjust that too.
Yeah.
The population of America was half what it was now 40 years ago. The population of America doubles every 40 years, historically. There were actually the population of Earth, believe it or not, doubles every 40 years. There are 7 billion right now-ish, somewhere in there. There were 6 billion at, I believe, 2000. There were 3 billion in 1960. There were about 1.5 billion in 1920. You got to adjust for that. I mean, yeah, there's going to be more ticket sales now than in 77, but who was available to get tickets in 77? You have to adjust for that inflation as well, not just monetary inflation, but people inflation. I mean, this is the mathematics behind economics and behind statistics, but it gets ignored. It gets ignored in every new movie that's a blockbuster that comes out. It's the highest grossing movie of all time. Okay. That's like saying I'm the best drummer in the room. Like, you know, if you ignore every other variable, it's easy to make any claim that you want and have it have merit. I'm not saying you should. So, what I want to do is I want to look at these data that I collected right here. And if you notice, there's a couple variables. You've got these years. I decided to make it a little bit easier to use. So rather than going 92, 94, 96, I used 1990 as a baseline and just measured off of that, if that's okay with you guys. It makes the math a little bit easier to play with. And then I stripped all the zeros off since the zeros seemed a little bit... I mean, as long as you know that it's in millions, you can put 35 and realize it's 35 million and call it good. So it makes the math and the presentation a little bit easier. So what I've done down here, and we're going to learn how to do this today in our technology, is here's the data table that we started with. Boom, boom. This is what's called a scatter plot. This guy down here is called a scatter plot. Now I want you to make peace with what you're looking at in this scatter plot. Make peace, make sure you can see what it's showing you. How is it the same as the data table above? How is it the same as the data table above? Who wants to take a stab? How are you getting the same information in a slightly different way?
You're looking at it linearly.
Oh, I gotta go for linearly. I like that. Did anybody take a look at this and go, you know, that data appears to be lying on roughly a straight line? Be honest, did anybody see that in the data? 2 of you. Yes. The first time I saw it, I didn't think that either. For most of you. I'm in the same boat as the rest of you guys. I looked at the data, I'm like, oh, that's cool. Let me make a scatter plot to see if there is some kind of an underlying pattern, because I didn't see the pattern right away. Very often I don't. I was just asked to do a bunch of work for my buddy Michael over at U of O. He's trying to publish a paper on different effects tied to the rate of endangered species in various countries. He's trying to see if any indicators are somehow tied to the rate of endangered species or protected status in these different countries. And the idea is I can't look at hundreds of columns of data and be like, I'm not Rain Man, I can't do that. So what I have to do is I have to put it all into a spreadsheet and grab certain ones, throw them onto a scatter plot like this and see if any kind of a pattern arises. See if any kind of pattern. Maybe it's that as the populations increase, the rate of endangerment increases. FYI, it doesn't. I tried that. It didn't work. That was my first go-to. I'm like, oh, it makes perfect sense, right? You always hear about the endangered animal species that are being crowded out of their environments. So maybe that's a logical connection. Well, as it turns out, it's not a statistically logical connection. It might be true for 1 or 2 species, but not for species in general, which doesn't make any sense to me, but unless this data's wrong. So I check everything. Well, here I'm just checking 2 things. I'm checking time. See that down here? Just that. And I'm checking uninsured in millions. So what's this right here? What's this little blue dot right here? 35 million people were uninsured in 1992. That's why it was 2 pieces of information. That dot contains 2 pieces of information, right? It contains a year, 2 years after 1990, and it contains a Y value, which is millions of people, 35 million uninsured. So you see how it contains both of those pieces? Because really, how many dimensions are up in this table? How many dimensions? There's 2, right? An X and a Y. This is no different than algebra, is it?
I just remember how to
Yes,
put it into.
do. Good. It's all coming back. Good. We're going to take that and hopefully run with it. So you've got an X and you've essentially got a Y. I've chosen to put time on the horizontal. Why would I do that? Why would I put time on the horizontal and not the uninsured? That's actually a really good answer, Carrie. I like that. Because time, especially because of the way I put it up there, time is linear. Although Einstein argued that, didn't he? But that's okay. Yes. Not moving at the speed of light. Nice. Time is a nice measuring stick because it seems relatively consistent. Good. Randy?
Because time is the independent variable?
Because good use of the word independent. What does independent variable mean? I love that. Independent variable.
Something you can't change.
Good. You know what? Yes. Something, Randall says, something you can't change. The independent variable moves forward or backward, but forward in this case, without being affected by anything else. Uninsured are going to be affected by many things, one of which is time. I mean, one of which is time. Even if simple populations change, but uninsured rates stay the same, the rate that it changes is going to be dependent on time. So in other words, time doesn't depend on anything. It just keeps marching forward as we measure it, with the sun going around, or the earth going around the sun. Sorry, I went Tommy there for a second. The earth going around the sun. But the uninsured rates are going to be dependent upon other things, who's in office and so forth and so on. But at very, very simplest, definitely the amount of time that's passed. Yes, good, very good, very good, very good. So we hear the independent, and then we heard the dependent up here. Good stuff, good stuff. So what I want to do is I want to focus on this scatter plot right here. I want to focus on this, and I want to chit-chat about, yeah, it's good. That's actually labeled pretty nicely. I want to talk about this. Aaron said something that piqued my interest a few moments ago. He mentioned, actually, what did he say a few moments ago? I forget now.